Good morning, everyone. Welcome back to the unofficial Handmade Hero Mac OS platform layer guide tutorial strategy thingy. My name is Ted Bendixson, and I'm here to help you get up and running following the series and learning how to make your own games. Really cool and worthwhile. Today, I actually don't have a ton of time, so I feel like it's just like, let's just jump right into it. Where we left off last time, we did video sync, and so we now are, kind of consistently hitting roughly 30 frames per second, and we feel pretty good about that. So if you notice, ooh, this is not what I want. This is a different thing. Okay, sorry about that. So yeah, we're consistently hitting 30 frames a second. Which is pretty much what we want. We're happy with that, and that's actually what actual Handmade Hero is at. So the way we did that, just for those joining, is we kind of set up like a query performance timer. We use our own frame rate timer to actually figure out and make the CPU sleep for a little bit, and then we spun up to it. So if we look at this right here. Now, today is going to be kind of more of like a cleanup day because really, first of all, I don't have a ton of time. And then second of all, we're really looking at, we have a few bugs, or rather errors, that we're getting. So from the compile process. So if I look at this, if I run my build script, you notice right here, these things, okay? So what is this? Warning, conversion from string literal to char star is deprecated, so we get this whole warning thing. I actually think that if we, just try, we probably don't need to necessarily like look at all of our warnings because, there are some options here. One thing we could do is probably just cast that to a char star. So let's try that out. So if we get that. So there's a few options there. We can either like disable the warning entirely, or we can just cast it to a char star before we. So if we just do this right here, and then this right here, then we can probably get what we want out of that. So let's take another look. So if I build this. Okay, so that got rid of it if we just cast it to a char star. But this kind of opens up sort of a list of to-dos or a little bit of cleanup that we probably would want to do. And I realized that in actual Handmade Hero, the compiler, like doing different compiler options or warning levels, was covered in a stream that kind of occurred before this. So this is probably a good time to kind of get started on thinking a little bit about that. So we're going to go back into our build script for today. And so that build script is in the code file. So if I look at my build script right here, there's a lot of things we have here, but what we want to do is actually right here. So there's a few options. One of the options that Casey uses is treat warnings as errors. Okay, and so what that does is basically, if you're compiling, then anything that kind of comes out as a warning will immediately be treated as an error from the system. So that's kind of like real strict mode. Really kind of forces you to reckon with any kind of warnings. I sort of like that. I kind of like the diligence of it. And at least, like, if you think about it, like, the whole point of warnings is they're sort of designed to make you think, right? To kind of like make you stop and say, oh, am I doing the right thing here? Like, and so the idea is that hopefully there would be a certain set of warnings in the compiler such that if you consistently remember to enable them, then you'll be productive, right? And what you want to do though is, like, you want to be pragmatic about it. So you want to kind of like know what your own weaknesses are. So you want to, when you're working on projects, you want to know like what are the kinds of errors that I tend to make, right? And so and like you really want to get into the details of like what are the sorts of errors where when I make them I end up like chasing going on a wild goose chase for a long time. Like, what are those sorts of errors? Like, if you could like list, how many times have you, made a mistake in your code and you end up like chasing after some like stupid phantom thing for a while, right? Kind of like my, like just a few episodes ago when I didn't have like file star fully uppercased, right? So I spent like 15 minutes just like chasing down this thing that I was like, didn't know what that is. So it's like, when you look at kind of compiler errors and warnings, you want to enable the kinds of warnings that, where when you address them, you know that you're more productive. You know that you're spotting things. And that's kind of, I sort of say a similar thing about like assertions. So if you have assertions in your code or like places where you know that, okay, like this has just gone so off the rails that it should crash here. And we actually want it to crash, because if it does crash in a debug kind of a mode, right, then we're going to be more quickly able to diagnose what the problem was. As opposed to say, I don't want to bag too much on like say JavaScript, but let's go there. Kind of one of the issues I have with JavaScript is because it's an interpreted language, it's like really difficult to debug, or it's like when things go off the rails, like it just kind of keeps on executing and doesn't necessarily crash. And worse than that, like you don't necessarily know like what line in your code it started to go off the rails. And so all of this is about, I mean, really a compiler is just a tool. All of this is about making sure that when your program is not running to the specification that you set out, that you're more able to quickly diagnose what the problem is. And that it doesn't just kind of keep running in this weird state where you don't know what's going on and you're like trying to figure out, okay, what line did this happen? That kind of thing. So that's why we turn on warnings. That's why we have errors. All of that stuff is to hopefully cut down on development time, right? Because if we're saving time, not going on a wild goose chase for bugs that we don't really know, that's just going to be overall better for making stuff. So that's what this is about. So the way I like to look at this is we treat errors as warnings, and we enable all warnings. And then what that is it's like a big block that we're kind of working from, and we sort of chisel down from there. And so we're about to kind of open up Pandora's box here. We're about to like get this huge slew of errors, and then what we want to do is ask ourselves, or rather a huge slew of warnings, and then what we want to do is ask ourselves, okay, of all these warnings, like which of them are worth addressing right now? Which of them are, okay, the problems in our code, versus which of them are something where we should actually just tell the compiler to shut up because it's not important. And there are going to be those. So anyway, first thing we do is we turn on -w error, and then another one we do is -w everything. And this compile line is starting to get kind of long, so we may want to consider moving these up here into another variable. So we'll probably do that. When I do this, right, I'm going to get a whole slew of things. Okay. In fact, so many I get like it just kills my compiler here, like fatal error, too many errors emitted, right? So now we have the glorious duty of going through some of these things and seeing what we want to do. So very first one, implicit conversion change signedness. So this is on Handmade CPP line 46. So let's look at that. Okay, and where, okay, so this one. Okay, so samples per second. Now why is that? So we probably want to look at what's going on with, oh wait a second. Yeah, so we have a game sound output buffer, that's right. It's game sound, okay, that's right. Yeah, so why is that? Because samples per second is like int 32, right? So, and then what that does is it's converting, see, and then tone hertz is actually, that's UN32. So samples per second is the only thing that's like, and that's an int32. So what it's saying basically is like, do we want to convert that to a uint32? And you know, there's a number of things we could probably do here. I don't really ever see why samples per second would be like negative. So we could just make that a UN32, and then so we're just kind of going back through, and now the question is, do we still get that, you know, that particular error? And that warning is gone now, so we're not seeing that. So we're getting something else. And now this use of OldstyleCast. So some of these, kind of before I started doing this video, I spent a little bit of time looking them up. Gosh, I guess, you know, this makes me the old man in the room using an OldstyleCast. So, you know, do we care about this? I'm going to say no. So this OldstyleCasting, I kind of looked it up. It's more like a C++ thing. So what is that? Well, basically, C++ has kind of some rules around, or kind of some, because in C++ there's all of these other ways that we can cast. So C++, that's an object-oriented language I'm not super familiar with, actually. I'm like more familiar with Objective-C and Swift and those. But basically in C++, there's like, you have all this like inheritance stuff, and so because of that, like casting gets to be more of a complicated sort of thing, because it's possible to like upcast and downcast things. So I can like upcast to like superclass or like downcast to a subclass. And since like most of the kind of programming that we're doing for Handmade Hero is really we're using a very small subset of C++. We really don't care about many of those features, including inheritance, actually. So we're really sticking mostly with C. And so this particular warning is not, I would say it's not not useful for this project, right? So there might be other projects where, like, you know, say maybe you're on a team and like we're going crazy with inheritance and like using all these C++ features. That may, you know, not doing OldstyleCast might actually be important on that team, where kind of everybody has made a different sort of business decision. But here, we're going to actually disable this OldstyleCast thing. So how do we do that? We go, you just go -w no, and then this the name of the error. So in this case, it's OldstyleCast. So I'm just going to copy that, and then yeah, so -w no OldstyleCast. So what this is going to do is it's going to just disable that particular warning, because we don't really care about it. And now we're going to build again. All right, so now you notice that all of those OldstyleCast errors, because we got a bunch of them, those are gone now, so that's great. Okay, so implicit conversion increases floating point precision, float to double, so that's right here, right? So we got this like double promotion going on here, and then another thing here, implicit conversion increases floating point precision, real 32 to double. So I'm guessing that maybe mpi is a double. That's my guess. So we could we could take a look at that. So what we probably would want to do is just like cast that to a real 32. So we'll go to 59. Okay. So that's my guess. Could be wrong. So yep, there's that. And then we'll just see kind of where we end up. Got a lot of errors with that one. Okay, that one seems to be gone now, so that's good. Okay, so comparison of integers of different signs, int and un32. All right, and that is in line 53. So obviously, you know, I think we want the signs to be, we want to have the same types here. So I'm going to say we're not going to disable that one. We actually care about that particular error / warning. So we're going to do that. You know, a lot of these too, like you have the option to you yourself can decide which of them you want to enable / disable, right? So you don't necessarily have to. You can keep it on for, you can turn it off or turn it back on, or you know, if you just want different. Sometimes it's useful to just like tell a thing to shut up for a bit. So yeah, so we're going back to line 53, right? Okay, so we'll just say sample index is now like a UN32, right? So we'll start with, so that ought to fix that one, right? Okay, and then line 70. These are not super interesting, but so we'll say that's a UN32. And the reason we're doing UN32 there is because we, you know, there's some things that we actually know about these variables, right? So we know that y is never going to be negative, right? There are times where we will do loops like this where y can be negative, or x can be negative, or you know, any of these things can be negative. But we know it can't be negative just because, you know, it wouldn't really mean anything in terms of like this particular buffer here. I'm not sure what it would mean to access like a negative space in that buffer, right? So like that would be out of memory. That would be like, you know, we're beyond the space in the buffer that we can actually write to. So we don't want that. It's totally reasonable to say that these are, you know, unsigned integer kind of thing. So we got that. Okay, so that was a thing. Okay. Anonymous structs are a GNU extension, okay? So I think this actually has to do with our the game, okay, wait a second. This is in the, I'm going to open up the Handmade. Oh wait, no, that's right, we didn't have that. I'm trying to figure out where my game, oh, here it is. I need to make a header file for this pretty soon. So what they're saying is that this struct right here is kind of an anonymous struct. So there's a few things we could do there. We could obviously just disable the warning. That would be fine. I think another thing we could probably do is just like, you know, go game buttons or like game controller buttons or something. Just give it a name, right? So there's a few things you could do there. I don't know. So we're going to do that. Okay. Anonymous struct declared or extensions. Anonymous types declared in an anonymous union are an extension. Okay, so probably we'll see what we get there. Cast from const char star to char star drops const qualifier. Okay, so the const thing we probably don't really care about that much. So we're actually gonna turn that off. There, you know, again, this is like if it's a problem that you have, you know, dealing with strings and like knowing if they're constant or not, or if like maybe you got a lot of people on your team and like some people care and don't, and it just gets to be this like thing. But I'm actually just going to turn that off. So now at this point, you know, this line is starting to get kind of cumbersome. We probably don't want like some super long kind of compile line. So I'm just going to pull some of this stuff up. So I'm just going to say compiler, yeah, let's call it compiler warning flags. And then we'll just copy these things in here, right? So we got that, and then we're going to make sure that we use that. So okay, and then another thing we could do is we could say disabled. Yeah, we'll call it disabled warnings, right? And then that way we can just kind of have like a long list of things that we are disabling. So, because that's just going to get to be pretty bulky. So we don't want that. We want just to kind of, you know, have some like level of control over that, and not just have a ton of them. So got our disabled warnings. We don't care about no OldstyleCast, and we don't care about no what else do we not care about? We don't care about this cast qualifier thing. So we're just, I don't know, you know, programming off the rails here. Who knows what could happen? So yes, we got disabled warnings. All right, and go back up and let's build again. Okay. Now, okay, so now really all the warnings that were inside of, okay, types cannot be declared in anonymous union. Okay, so, you know, now I'm kind of thinking we want to, so we're going to want to get rid of our, so I tried to fix that thing in here by just giving it a name, and now I don't care. I'm just going to disable the warning because so far it hasn't been a problem, and I just, you know, screw it. Don't care. So cast from const, okay, I thought I got rid of that one. Oh, that's right. I need to say W no. So, right. Okay, so there's that one. You're just going to have to keep running this and running it until you get, see, we're still at like 20 errors, right? So we want to get back to, you know, turning off some of these things. So I'm hoping that, so I have to go in like, you know, 30 minutes or so. I'm hoping we can get through all these. Anonymous struct, so we're turning off this WGNU anonymous struct thing because we don't care. So we're going rogue. And, you know, if it becomes a problem later, then we can do something about that. But I don't really care, so we're going to get rid of that. Okay, anonymous types declared in anonymous union are an extension. Fine. We're going to turn off this turn off W nested anon types because that's like not important. So let's do that. And this, you start to see this list of disabled warnings gets pretty large, which is okay. Okay, padding size of debug. Read file result with 4 bytes to alignment boundary. Padding size of debug. Not really sure what to do about that one. Let's look that up. Hopefully it has some time here. So I'm just looking at -w padded just to see. Really? All right, let's look up the text. Okay, padding size of with bytes to alignment boundary. Fine. It's probably like not properly. You need Stack Overflow. Okay. Yeah, I should probably know about this actually, which is sort of embarrassing. There's no real problem. The compiler's allowed to insert padding after struct members. Yeah, if we switch the order of stuff, it's 4 bytes. Yeah, we need to like probably So what this comes down to is really a matter of right now, do we want to care about this, right? So I don't think that we necessarily want to not be able to build the game just because like the padding on a struct on some structures does not match proper alignment. Like obviously, yes, it's more expensive if the CPU is executing a lot of instructions that take things that are not aligned properly. But think about this, in this particular use case, like we've got debug file, read file result, which we're only using like a few times. It's not like we're churning through a bunch of these, right? So the alignment is not going to matter as much here. And so what we want is really to, we would probably later on, when we're starting to think more about performance, we would want to turn this warning on so that we knew all of the places in the game where the padding is incorrect. And and those are the places where we would want to look at optimizing it, right? So we'd want to know there. But I don't just want to be able to like not build because some things are not padded properly, if that makes sense. So I'm going to disable this for now. And then what I'm going to do is I'm going to make a note just saying, hey, you may want to turn on this padding thing because it's kind of important. So we'll do that. This W padded, right? So we'll do W no padded, right? So gosh, how do I do comments in bash script? I actually don't know how to do that. Word causes that word already can. Okay, so good. So we're gonna say okay. Note TED. Can be useful when we want to know which structs are not properly padded. We have disabled it for now. Okay. So there'll probably be a few warnings that are sort of like that, where it's like we're going to disable them just because we're going to disable them because we don't want them to block the build, but they could provide useful diagnostic information later on, right? So that's kind of the thinking there. So go back up here. I'm going to run my build script again. And now okay, so that's no longer a thing. Implicit conversion turns floating point into integer. Where is this? Game state tone hertz. Okay. So handmade cpp.198. Okay. So tone hertz, I believe, is real 32. So we just want to make sure that everything is like real 32, right? So that is going to be, yeah, so we want to cast all of that to real 32, right? So that'll probably be good, I think. Let's see. Okay, so there's that one. Do we care about unused variables? I I'm gonna say no. Just because there's, yeah, that's kind of another one that's sort of like padding, is like, if we really wanted to like kind of do like a thorough clean on the thing, we would turn on, turn on unused variables. But for this, it's like, that's just going to happen kind of while we're while we're sort of like doing an exploration of what the product or game engine, or this really applies to any kind of software development, not just Handmade Hero or not just making games, but it's a matter of all of these things are useful. It's just a matter of when are they useful to you, and when you have more control over them, knowing when you want to do a more thorough diagnostic versus when you don't. Right. So in this case, like I'm not going to flip out about an unused variable right now. It's it's not important. So, I'm not even going to make a note, because we know that we know that like what we've disabled, and we know that we can go back over these, and we know that we can just turn them on if we want to get more thorough diagnostics. So that's that. Okay, still didn't get this right for some reason. Wait, is tone hertz tone hertz is an integer, isn't it? It is, isn't it? Okay, so that's it. Okay, so, oops. Yeah, so tone hertz is an unsigned integer, 32. So that's fine. We'll just convert everything to that. That's all right. Unused parameter. So do we care about unused parameters now? I forget why we even had dest count. Probably for destination bounds checking. I'm going to turn off this one too, just because it's like, yeah, I mean, these are all, the unused ones, like, it's something where if you want to just kind of like really go and like I said, if you feel kind of like in cleanup mode or whatever, maybe like you're kind of in that time of your day where you're doing something less cognitively demanding. You just like don't want to like really think. You could go back over some of these things and clean them up. So there's that. Okay, so comparison of integers of different signs, int and size t. Where is this? OS 10 main, line 55. Okay. Yeah, so we're just going to do unsigned here again, 32-bit. So that's fine. We're just working through these. Sign conversion, okay. Implicit conversion changes signedness long to size t. Unsigned long. Okay. Sign conversion. Oh, this thing. Right. Gosh, there is more in this than I thought. We still have not hit the error limit. I don't want to just turn these off too necessarily, because some of these are going to be important. So we may need to, although there are things where we're not going to care. So yeah. Oh, wait a second. W unused parameter. Okay. Sign conversion we care about. So minus path file name. Because path, okay, so what I need to do is look at this path thing here in path, right? File name is just char star. What's it? Long to size t. So right? Well, I mean, if we just cast the whole thing to size T, I think that's okay. I think we're okay with that. So I'm going to do that on line 85, right? Not all of this is perfect. So let's build again. This is a long list of things to go through. So you don't even, I'm doing this now, but you don't even necessarily have to do this, right away. Implicit conversion changes signedness, int to size T. Okay, string length. Line 87. Why? Because string length. Oh. Wait. Gosh, let's just do unsigned here because, like, again, how could a string be negative length? So yeah, I'm gonna definitely go there. So that couldn't really happen. Okay, implicit conversion, 88, and wait, right, dest count. Oh, all right. So dest count, I'm gonna also do un32. So that's fine. Sign conversion, okay. And then this thing, ftel, changes signedness of long to un64. So I think I'll just cast that to a un64 from ftel. We actually want that, so we don't want to disable the error. Yeah, this is from our debug file IO stuff. So we definitely want whatever ftel gives us to be unsigned 64-bit integer. Generally file sizes. So what you'll notice, if you're kind of getting into C programming, is on a lot of systems, certain kinds of things tend to be represented as unsigned 64-bit integers. One of which is file sizes, because there's a lot of possible file sizes. If you have like a 32-bit integer, then I think like right around like 4 gigabytes, the whole thing would overflow. So obviously we can have file sizes bigger than 4 gigabytes. Other things tend to be unsigned 64-bit integers, like timestamps, right? Because otherwise, if it were 32 bits, then we'd overflow. I don't know exactly when, but it would suck. So we don't want that. Let's see. So, all right. So we're just kind of working through these. Implicit conversion loses integer precision, un64 to un32. So that's on 129. We just want to cast the file size again to an unsigned 64-bit integer. 64. Where do I get file size? So file size. If file size. Wait a second. Result.content size. Does a debug file result? Is that? Hang on. Debug file result. Yeah. I'm going to make this a U64 because you don't have to. I'm going to do it that way just because I think on at least on a lot of the systems that I'm interested in building on, this could change. So it's meant to be cross-platform though, because you could be on 32-bit systems. I'll turn it back to 32, and then I'll just figure out how to handle that on. I'm going to say it's okay that we cast this to a UN32 when we're dealing with the cross-platform code, right? So I think that's kind of what the thinking is. So we don't want to disable that. We want to know that that's what we're doing, so that's fine. Implicit conversion turns floating point number into integer. Okay, this thing right here, right? So buffer width, buffer height. That's in 209. Right, so I'm guessing that, so game off-screen buffer, the width, so we have that right here. Yeah, so we're just going to cast a float. We're going to intentionally cast an unsigned 32-bit integer for that as well. So I think that just makes sense because, you know, on this system, the Windows content view and size and width or whatever, that's a floating point number, I believe. So we're okay with that. Going to do that. Okay. We are making a little bit of progress. I have to go in 20 minutes, but, you know, do not fear. Okay, so no previous prototype for function. You know, for this thing, like, we give 0 things that start with an S or an F with respect to doing things in an object-oriented way. So we don't care if things don't have prototypes. So we're just going to say, just turn that one off. So not important. We don't need no stinking prototypes. So I know it's totally rogue programming here. What are you going to do? Don't need a header declaration. Okay. Implicit conversion from nullable pointer. Okay, so now we're starting to get kind of into some like Objective-C stuff. Nullable pointer, NSString star nullable to non-nullable pointer ID. I'm just gonna turn this off because I don't care. Like, it works, and this is not a it just is not an error that I care about. It's like we don't have a lot of code that deals with like null, like possible null and non-nullable, and so it's not a problem that we have. If it becomes a problem that we have later on, then maybe I'll do something about it. So that was a lot of those. Now I don't have any to go through. I'm guessing we'll just like get more and then we'll like stop at the limit. Okay, so we're still at some serious problems here. Okay, so now we've got implicit converter changes signedness int32 to unsigned int. Okay, that's right. So bytes per sample and sound output is what? Okay, so I got to go back. Bytes per sample. What do we have that declared as? Actually, wait a second. That's in my, yeah, that's an int32. Why is that an int32? Doesn't really make sense if you think about it. Like, when is that ever going to be negative, right? So, I'm totally cool with that being an unsigned int, right? So that's fine. Okay. Sign conversion, bytes percent. Okay, so we just changed those. Don't care. Global render width increases floating point precision to double. Okay. Why? So what is global render? I thought global render width was. Do we care about double promotion? We didn't have that as a double though, did we? Just a second. I'm going to go through and see line 637. Okay, those are real 32s, right? Is it just a, oh, is this, it assumes, okay. So we know this is real 32, but maybe like screen rect, like that size dot width, maybe that's a double or something. I'm totally guessing here. We could look it up, but I'm being kind of lazy. Okay. Maybe. Okay. Did that do it? No. We still have this. Implicit conversion increases floating point precision. Float to double. Okay. Oh, is it? Maybe it's this like 0.5 that's giving us troubles. Still have a problem with that. Double promotion. Okay. Increases floating point precision. There. I don't know. It's ns make rect. So let's figure out what ns make rect does. Okay. What are my parameters on that? CG float. What's that? Okay, so that's a double. Right. All right, so here's what we're going to do. We're going to make the global, we're just going to cast it to double because this thing wants a double, right? So I don't so we actually want this to be real 64, I guess, call that. We have real 64. And that doesn't matter. I mean, most of the time we don't want to use 64-bit 64-bit floating point numbers, just because, well, it has to go to, it comes down to like the efficiency of the process. So, but I'm going to just, you know, for the purposes of dealing with Mac OS, we're gonna be okay with that. And now let's see if we got our thing we wanted. Okay. Yeah, so that's gone. That's good. We still have some issues with this this here, N32 to UN32. I guess audio frame size is like, yeah, so audio frame size, I want to find that. That's probably like an integer that should be an unsigned integer. So 539. Audio frame size, yes. In fact, we want both of these to be unsigned because, again, it's not going to be possible to have like a negative audio frame size, right? And it's also not going to be possible to have like negative number of seconds for a frame of audio. So these are just things that cannot happen. Okay. This C++ 11 extension, okay, you know, this we don't care about because we're not doing much with C++, so I'm going to turn that one off. I would not blame you if you just, you know, copied all this from, thankfully we're going to put all this in the repository because it's a lot to go through. So, okay, so we're still having errors. Sign conversion. Okay, implicit conversion changes signedness, UN32 to int. Okay, so it looks like all my access flags and allocation flags are giving me trouble. So I'm gonna, you know, get to those. Okay, so let's go back. This has to do with when we did memory. Wait a second, that's, okay, so that's UN32. Access flags, allocation flags. What is the problem here? UN32 to int. Oh. Okay. It must be that the actual like end map just takes an int 32. So I'm just going to change that to int 32 here. And I think the same with allocation flags. Let's see if that cleans it up. It seems to. It does. Okay, very good. Just kind of getting through this. I'm going to have to get going soon. But, you know, thankfully, like, a lot of this stuff is getting done. So, let's see. We're really only at we're only just a few small things here. So conversion changes signedness unsigned int to int32. I'm guessing it's this. Okay, so target queue bytes. Okay. Yeah, and I think target queue bytes, I don't see why that couldn't be like unsigned integer either. So I'm going to go back to that. Right, and same with like latency sample count, that could also be unsigned. Like, there's really no reason why not. I guess like most of these are just sign conversion problems, aren't they? Okay. See, we're almost, oh, do you see that? 19 errors. We didn't like crash because we ran out. Okay, so let's get this done. Implicit conversion, change signedness, unsigned into int32, sign conversion, int32. Bytes of lock, that's going to be UN32 as well. And that's going to be UN32. So that's fine. Okay. Only 8 errors. Okay, so implicit conversion loses floating point, doubled real 32. Where's the double? Okay, it's like 1E9, maybe. So yeah, those things down there. Down here at the bottom. See, we're at the end of the code. Okay, so I think we just need to do like real 32 here, right? And then real 32 here as well. So that's probably fine. Sorry, I've got this meeting in like 5 minutes. Let's see. Increases floating point precision to double, frames per second, milliseconds per frame. Okay, so we actually want to do the double. We want to promote, so we're going to do that. So we're going to. I think it's just that this thing wants like a real 64 there. So whatever. These are like NSLog functions. So because we're using like Apple's kind of logging. Okay, fine, do that, all right. And then int and int, so sample index. Okay, so that's probably just like something needs to be, what do we say, 860? Okay, yeah, so let's just do like UN32 there. Because it's never going to be negative, we know that, so that's fine. I don't know, this is getting kind of pedantic about integers, like maybe you don't care. I'm just kind of showing like, here's how you can be pedantic if you want to. Okay, we built. I don't have a ton of time to look at this, so you know, keep your fingers crossed. Hey, I'm hearing a tone. I still have control. It still seems like we're operating at our 30 frames a second. I'm gonna say, you know, I'm gonna plant a flag and declare victory because I gotta go. Obviously, you know, we will take a look at this in a little bit more detail. I sort of apologize because, like, you know, when I'm following Handmade Hero, like, these are the kinds of streams that I just, you know, it's like no offense to Casey or anything, but like, these are the ones I just hate to follow because it's like there's so many changes to the code, and it's just like we're jumping over the file, jumping around the file, like. I wouldn't blame you if you just wholesale, like just copy the code in the platform layer from today. And, you know, like trying to follow along with something like this, like maybe watch it. And but there's just so many code changes in so little period of time that it just gets really tedious. And like, especially if you're like on, like when I follow the series, like I'm on YouTube and like I'm constantly like rewinding back to a point and playing it over and over again. And then like a friggin' ad plays again. It's just like, oh, it's super annoying. So I would not blame you if you just wholesale like copied the code from the platform layer for today, because yeah, this is just really annoying. Obviously, a few closing notes, like go support Casey, fantastic work. I was just at Handmade Con, lots of really great people doing some amazing things, so support them, go buy a copy of it. You can support me on Patreon, and yeah, so next time we'll kind of get into some other things that are not cleanup, but I felt like this is a pretty good use of an hour, so I will see you next time.